These are the test corrections for Chapter 12, taken on April 15, 2016. This is version A. Directions: make sure to show all your work and box your answers. Question number 1 is multiple choice, acting a factor completely. Your A value is 1, B value is 2, C is -15. So every time you see the word factor or factor completely, you should be thinking about a greatest common factor, making all these numbers smaller, which you can. You're going to take A times C, which goes up there, which is -15. B value goes down there. Then you're trying to think of two numbers that will multiply to be -15 and two numbers that add to be +2. Those two numbers are +5 and -3, and those become your binomials, x plus 5, x minus 3. Question number 2. Same thing. In this problem, you do see there should be a hint that all these are even numbers, so you should have taken out a greatest common factor of a 2. And when you do that, you'll get x squared plus x minus 6. If you don't understand that, you can always distribute to see how it goes back up here. Then essentially you're just going to do your x box here. Remember, if a is equal to 1, you only have to do your x method here. A times c, this is your b value. The two numbers you need to think of are 3 and -2. And those become your binomials, and that would be your answer D. Now there is a second way of solving or factoring here. Let's just say you don't recognize the GCF. Math is very forgiving. So you do A times C, which is -24. Your B value is 2. Now notice this puzzle is going to be a little bit bigger. The numbers are larger. Two numbers that multiply to be -24, but those same two numbers add to be +2. That's -4 and 6. Now because you're doing a factoring here in this second scenario with A is greater than 1, you have to put them into the box. So here you put in -4x, add an x there, so it's 6x. The first term, 2x squared, goes in the top left, and then the bottom right is your c value. And you'll notice that the common factor you have here is x, and this going in this direction would be 2x. This would be -2, and this would be a 6. And remember, you can always multiply to get what's inside the box. So here I have x minus 2 and 2x plus 6. But you'll notice that's not one of the options. And the reason why is 2x plus 6, you can find your greatest common factor, which is a 2. And that 2 you just put in the front, and then it looks like our answer in D. Question number 3. Multiple choice. This one says solve. So the difference between questions 1 and 2 and 3 is that questions 1 and 2, you just have to use your x or your x in your box method. If you don't understand, just keep doing both. But in this problem, you're just going to take it one step further and do the zero product rule. So you're going to, in this problem, A value is 1, B value is 3. This one is not set equal to 0. So when you're solving quadratics, it should be equal to 0. So you're going to have to subtract 40 from both sides. And C is -40. When you do your x here, you'll recognize that you'll have your binomials to be x plus 8, x minus 5, like they are here. And you're setting them equal to 0, and this should be your hint to apply the zero product rule. Zero product rule essentially says one of these has to be 0, so you're going to set both those equal to 0 and solve. Add 5, subtract 8, x is both equal to 5 or -8. And you can always take one of those numbers, put in for the value of x, and you'll see that'll equal 40. Question number 4, multiple choice, says solve. So I have x squared plus 4. Your a value is 1. Your b value, though, is 0, not +4. And then your c value is 4. So if you put that into your x method, there are no two numbers that multiply to be +4 but add to be 0. Remember, when your b value is 0 here, these two numbers have to be exactly the same, but one has to be positive, one has to be negative. Okay. When this happens, we call that, they're called prime factors, or it can't be factored. Another example of a prime number, for example 3, the only numbers that multiply to be 3 are 1 times 3, so 1 in itself, so which means that there's not, these cannot be broken down to any other factors. Question number 5 says complete the table. You have y equals x squared minus 4. Essentially, you need to put in your x value here first, and then do the exponents. Make sure you're using the order of operations PEMDAS. And the other version, the students got confused with a minus sign there. So you put in -3, -3 squared is +9, +9 minus 4 is 5. And if you go ahead and substitute all your x values, you'll get these as your answers. And you'll notice that quadratics are symmetrical, which means that this is going to be your vertex, and then all these other values right here are mirroring or symmetrical, are the same. 5b says to complete the first and second differences on the table to the left. So as you're going down, you have to do a math operation, or you can think of it as this. 5 plus something equals 0. So 5 plus -5 is 0. 0 plus -3 is -3. And you're thinking, how do you go from -3 to -4? Well, you would have to subtract 1. So -3 minus 1 is -4. And you keep doing that. And then you'll recognize that your second common difference is the same. So 5c says, using the table, does the table represent a quadratic function? Yes, the table represents a quadratic function because it has a second common difference of -2. If it was just a first common difference, this number is all the same. That's called linear. Now, to get partial credit, you can look at, there is a scoring rubric on the Math B video of how I scored this one. Something like if you got 6, 5, or 4 of these correct here, you got 3 points, then 3, 2, or 1, I gave you maybe 2 points, or something like that. Now over here, if you did find at least one difference correct, I gave you 1 point out of 2 for number 5b. And for 5c, if you said something like, you know it's quadratic because it's the power of 2, I give you 1 point out of 2. Or if you just said yes, I give you 1 point. Remember, it says use the table of values. If you turn the page, you are given this function called function j of x, or function j, and this is in standard form. You know it's in standard form because you see no parentheses. There's one. Both vertex and intercept forms has parentheses. Intercept form has 2 sets of parentheses, which you'll see in a second. So 2 points for having standard form. For 6b, if you got at least one of those right, I give you 1 point or 2 points for all of these. These numbers just come from the coefficients. So there's an invisible 1, so -1, b is -2, and c is +24. Then with your a, b, and c value, you can only find the vertex using standard form. So here you're going to get your a, b, and c, and then you use x equals -b over 2a. You'll notice in standard form, this is the front part of the quadratic formula. So don't forget that minus sign there, so just leave it there. Your b value is -2, your a value is -1. 2 over -2 is a +1. Take the opposite of that, your axis of symmetry is -1. Now whatever you get for your axis of symmetry, notice how it says x. This becomes that part there for your vertex. So this is your x coordinate and this is a y coordinate, so you just put that there. And now essentially what you're going to do is you're going to substitute a -1 for every x value. There and there, you're going to square it and take the opposite of that, which is -1. So -1 plus 2 plus 20. What happened here? I went from, I added these two and then add those and you'll get -1 comma 25 is your vertex. 6e, sketch and label the graph with the information you found in 6b, c, and d. So b tells me your axis of your a, b's, and c's. So your a value is negative, so we know it opens down, and your c value tells me here in 6b that this is your y-intercept. So that's your part right there. 6c is telling me your axis of symmetry, x equals -b over 2a, which is x equals -1. And then you find your vertex, which is -1 comma 25. So when it says sketch it, meaning draw something and then label it. So from the previous video or version B, you got 1 point for knowing it opens down. You got 1 point for labeling the y-intercept. You got another point for labeling essentially your axis of symmetry, and you got 1 point, that was the down. And then D was for finding the vertex there. Okay. So now this part says complete the table using your graph above. Figure out the domain and range. Domain means going from left to right. So in-row notation just means this notation here. So if I start here on the left side, I have a arrow, and the last thing you'll touch is always an arrow here in this case. Anytime you have an arrow to an arrow that's negative infinity to positive infinity, the reason why it's negative because it's negative numbers, and this would be positive numbers. And notice how anytime you have infinity, you should have parentheses in this case. Now, anytime you have this negative infinity to positive infinity, it essentially means for inequalities, you always write all real numbers, or you can just draw this special R there. The range is from the bottom to the top, so the first thing you'll touch going from the bottom going up, imagine if I was be able to drag a line here, the first thing you'll touch is these arrows, which means they're coming from negative numbers or negative infinity, and there you're going to stop at 25 on the y-axis. So you're including that because it's a closed circle, so that'll be a bracket. The range, or all the values you can think of going from, are notice how it's 25, or you need numbers smaller than 25, so y is less than or equal to 25. Remember, it's equals because you have a closed circle and that's a bracket. All right, here is a intercept or factored form. You know it's an intercept form because it has two binomials there. And there's no constant out here, which would be the vertex form. So 2 points there. Axis of symmetry. Essentially, you're going to recognize this, and you should see that it's already factored. So I'm just going to skip down here to finding the zeros, which means you just essentially do the zero product rule, set them equal to 0, and you'll solve for x equals positive 1, negative 7. If you got one of these correct, it'll give you 3 points. So when you have 1 and negative 7 now, I'll give you a visual. You essentially need to find the midpoint. The midpoint is your axis of symmetry. So negative 1 plus 7, which I did the math up here. And you divide that by 2, or your midpoint, so your axis of symmetry is negative 3. We learned in the previous problem, you take this now and make that your x value. Make every x value negative 3 and above, and you'll get negative 4 times 4, which is negative 16. So negative 3, negative 16 is your minimum. And that's how I graded your problem. And A is graphing up. Question number 8. Okay, you'll notice that this is not in standard form. It's not in standard form because we have parentheses, so you're left with vertex or intercept or factored form. This is this is vertex form because you have the power of 2. That's your other hint, and it has a constant out here. So vertex form, you should be thinking your A, H, and your K. There is the form right here. And notice that in the formula, it does have a minus sign. Well, in the previous problem here, I asked you guys to change that to a plus. So a plus means minus, minus. So your A value is going to be negative 2. You have your X, you have that minus sign, therefore H is negative 1. And your K is whatever is outside that and to the right of the parentheses, which is a 1 here. So this becomes your axis of symmetry, or line of symmetry, which is X equals negative 1. And your vertex is essentially H comma K. That's why I call it vertex form. So negative 1, 1 is your vertex. Okay, you're going to take all of those parts and graph it. So 8B told me your axis of symmetry. 8C told me your vertex, negative 1, 1. And then you know it opens down. Notice how in vertex form you aren't really finding any x-intercepts there. Okay. So using this graph right here, it says complete the table in interval notation using your graph from 8D. So up here, they want to know where it's increasing. Increasing basically means going from left. Increasing and decreasing essentially means going from left to right. Where is it going up and where is it going down? So the graph is going up from here, which is going left. That's negative infinity, and we're going to stop at negative 1 on the x-axis. Now you might think you see an arrow pointing down. That would be incorrect because just imagine you're going from left to right. If you hop on the slide here, you're going up. Now in this problem, you are not including, it is a parentheses because here you might think it's a closed circle, but here it's not increasing nor decreasing. Decreasing is where it's going down, so that'll be from this point going left to right, and that would be positive infinity, so negative 1 to infinity. Okay. Question number 9. All the seniors should know this answer. It says Savannah High School has 5 student learning capacities, SLCs. Name one of them. Here are the SLCs here, and we gave you partial extra credit, meaning 1 point if you got something like, if you wrote academically accountable, but if you got personal, then we give you 1 point. Okay. Hope that was helpful for you to study for your finals and do well in your Chapter 13 test, and even help you with your quadratics project. Have a great day.